Suko is doing his favorite new thing where he climbs around on the speaker and rubs his face menacingly against all the cables that are vital to this very video production. I had to wait for an NVEnc NVIDIA video encoder channel to be free to get this stream started because I was doing some background transcoding. My understanding is that that's not actually a hardware limitation so much as it's an artificial limitation in their driver so that they can sell more chips. And there's probably some way to work around it, but I haven't bothered. Now Tuco's climbing around on the keyboard. Also menacingly. Whoa. You just knocked my safety glasses into the trash. Tuco, can we do something about this? Oh gosh. Let's make sure all the platforms are working, but welcome back to the stream, folks. Looks like we're live on YouTube and Twitch. Probably on the diode place. Oh man, it is actually much easier to deal with this multi-streaming setup with a little bit more automation. So the little bot that announces the stream links has been kind of helpful. Oh, Tuco, can I just move you? Tuco's the new camera operator. He is purring loudly and rubbing his face against the cabling. For folks who don't know Tuco, he is very interested in wires. And now he's biting the Velcro ties. Yeah. See what I have to put up with here. You coming down? That's better. I mean, it's kind of cozier for me when it's dark, but all the video looks better when it's well lit. go to the real world briefly, maybe. Tuco's wandering around. I'm not going to try super hard to get him on camera. We can just observe him from overhead. So between yesterday's stream and today, I took the rest of the hardware out of the voting machine's awkward plastic enclosure and set it up here on the bench. So I've got the CMOS battery attached, which is literally just a 3AA enclosure with a sticker on one of the wells that says, "Don't use this one, please." And that one's shorted out. Oh, Tuco. And then Tuco's discovering the printer, which I added. And I bet he's going to try to chomp that cable. Tuco. He loves thick rubbery wires like that parallel printer cable. I should really put some cat proofing over it. So yeah, the printer and serial I/O board here. This thing that's marked audio, I think that's a serial port that they rewired with some non-standard power. There's another bodge here, which I'll take a closer look at in a second, where they just super glued some wires to the board. Gonna cover a couple of the wires that Tuco likes to chomp, especially. Yeah, that really captures all of it. There's the LCD and touchscreen assembly on the left. There's the CMOS battery here, which is under a door, so that those are user replaceable. And this is a little breakout board that just doesn't have any active components on it. Actually, I scratched that. There are 2 chips on the other side on this unused port. I'm not sure what that's about. We might want to take a closer look at it. There's like a modular style jack here that wasn't used. I'm not sure what that's for. There's a DB9 serial looking kind of jack with these power bodges where literally there are some wires soldered from the printer's power supply to a couple of the pins on there. And then a special purpose dongle was attached with screws in a way that was likely meant to be permanent. So that seems to be another kind of bodge where they needed another external serial port for audio, but they also needed some power, and so they bodged it through that way. And then this looks to be a normal parallel port, which is driving this thermal printer over here. So it supplies parallel data and power over this barrel jack to the thermal printer. And then normal motherboard. This daughter card here is a LVDS transmitter for the screen. There's a parallel bus on the LCD controller itself and on the graphics chip, but they have LVDS receiver and transmitter chips that run the signal over this long cable, and that's on a separate little card for some reason. Would make a very convenient spot to plug in like a custom video grabber card if we wanted to go there. And then on all the way on the right side there, hanging off that alligator clip, is a smart card slot and a controller board. From some of the mentions I've seen in the software, I'm pretty sure that the card itself communicates over I2C, and it looks like it's connected pretty much directly to something on the motherboard. I'm guessing something on that PLD that we looked at briefly, which seemed to be mostly GPIOs on the ISA bus in that little lattice PLD. That little board mostly seems to be there for switching the power to an eject solenoid on the smart card socket. And so I also discovered that that eject solenoid causes like massive electromagnetic spikes every time it goes off, which might explain some of the ridiculous levels of like ground strapping between the components as this stuff was installed. And I haven't wired up all the ground strapping here because it relies on like screws that go into the plastic usually. So, and I checked that like most of the grounding is still accounted for via the regular wiring, so it's not like this stuff is floating relative to each other. But I think that that extra large ground strapping was there partially to deal with EMI from stuff like that. So just to keep that from introducing havoc into the entire system, I have the solenoid from the smart card disconnected. I think that's everything that's changed. So I was going to boot it up and try to get some video of this thing using the printer, but like off stream before I started this, as I was setting up, I tried that briefly, and this was having trouble talking to the touchscreen. So touchscreen still seems to be kind of hit or miss. I don't know what's unreliable about that right now, but let's give it another shot. Maybe we can get it to boot in a state where the touchscreen is usable. Maybe not. If so, then we can test the printer. If we feel like getting the touchscreen to a usable state, it would actually be kind of cool to just play around with like modding the menu. Like, basically the like goal that I set for myself with this is that I want this to be a useful like prop for videos, basically, where I can get this to boot into arbitrary software. And it seems relatively simple enough just by modifying the compact flash card with a different operating system image. That just takes some debugging. So that's another kind of thread that we've got going here. But then just to understand the system better, it's been interesting just to try to like figure out what the regular firmware for this is doing. So running that in emulation and looking at the IOs that it performs both in QEMU and on the real hardware has been interesting. And yeah, the software that normally runs the voting machine doesn't really get very far in here. It gets to a main menu. We can print some stuff, which is kind of interesting. But we can't actually run an election without some parts that I don't have, like the controller software and the memory cards. I'm going to turn off most of these lights so we can get a better view of the screen for this part. Oh, that's a good question about the LCD in the back there. It is a text LCD. It's a pretty run-of-the-mill, like 16 by 2 text LCD that you'd see on a lot of industrial equipment, especially in the late 90s. That whole assembly was mounted on the back of the machine, and it's intended to give status information to the poll workers. So that's where they put stuff like diagnostic messages, and there's some sort of low-level stuff where, you know, like you can adjust the screen calibration and the screen contrast via that So it's kind of weird. I don't entirely know why they needed a separate screen just for that. It's probably just that they really only wanted the front half of the machine to be for interacting with people that are actually voting, just based on how the machine was mechanically designed. It's easier for poll workers to be doing stuff all on the same side of the machine. So it was probably just that they wanted some kind of user interface that's on the same side of the machine as like the switches and connectors and stuff, and not the user-facing side. And that's actually only got one button. It's behind the microscope from this view, but there's a couple of just rotary toggles they're just two position selector switches. There's one that's a power switch, which is how I've been turning it on and off this whole time. And then there's one which is a polls open and close switch, which does not seem to have any effect when you don't have the memory card in place. Those two red pips on there are not buttons, they're just LEDs, and I don't know really what they're meant to be for. They're both basically like power / boot up status indicator LEDs. Like one turns on and then the other, so there's probably some diagnostics where they're like, oh, is your polling machine having trouble? Is it showing one light or two, over the phone? There's probably some stuff like that, but they're not labeled. Boot loop now. This is not the CF card I actually wanted to boot. It was just the one that was in there, but this is the one with that little toy operating system. Seems to be running unpredictable code, because first it rebooted and now it filled the screen with garbage, so I should probably turn it off. Well, of course it's not powering off cleanly. Came from the printer. I don't want to move the camera, but that little text LCD says AVC Edge power up. Please wait right now. I think the screen just takes a minute to warm up. Maybe the background's intentionally kind of gray. Okay, I think at this point it's supposed to be interactive. Okay. I'm gonna try triggering the touchscreen calibration mode, because I can't actually use the menu in this state. So I can't actually try the printer. So here, I'm just holding down the yellow button as the application boots. It's normal for it to start up with like uninitialized video memory for a minute there. So it just shows whatever was last on the screen, plus some intermediate garbage. Okay, so you release the button to activate. I've got the gray screen again. Still no touchscreen. Yeah. Come back to that in a second while the oscilloscope boots. I also have a theory that this might act differently if I just wait for a minute, because I'm pretty sure I saw this thing at one point boot into a state where the touchscreen wasn't working, and then I left it alone for a little while and the touchscreen was working again. So I'm almost wondering if there's something that is intermittent about the touchscreen controller, like microcontroller, and maybe it sometimes manages to reset itself again into a good state. So we can try this other experiment in software land for just a sec. Alright, on the last stream I was kind of looking at these two kind of parallel ideas. One being that the firmware that this voting machine normally runs does not run on emulators and doesn't run on different compact flash cards. And then also the idea that so far the other operating systems I've tried on this same machine don't boot. And so I thought those two things might be related. After the investigation on the last stream, I'm pretty sure they're not actually related. I think that the error with the voting machine application might actually be due to some like actual attempt at copy protection on the code, whereas I think that the other issues might be more just compatibility with sort of half-baked BIOS modifications rather than some like actual attempt at locking out non-standard software. And two cones back in. So we were running this in QEMU and it was working out all right as far as the I don't know, the code that we had reverse engineered so far. So we were looking at the hey Tuco, don't claw at the screen, that's rude. Gosh. So yeah, we'd looked at the two boot sectors. There was a main boot sector and a partition boot sector. The main boot sector turned out to be like, I didn't recognize it as like a standard DOS main boot sector, but it did have sort of the basic behavior that you would expect from just an extremely minimal MBR, where it reads the partition table, looks for a boot flag, and then loads the partition's boot sector. The one thing that I noticed that was weird about it is that it seemed to be hard coding an assumption that it was booting off of the first hard disk instead of using whatever the BIOS said that you were booting off of. So my understanding is that normally there's a register that you fill on entry to a boot sector to tell it where it is, like where it's been loaded from. And this MBR that was on the machine when I found it didn't have any of that. It was just assuming it was actually using the same byte that it grabbed from the boot sector as the boot flag, the OX80, and just always using that as a hard disk ID. So a little weird, but nothing that would keep it from running on an emulator or a different PC or a different compact flash card. And then I didn't look into super deep detail on the next bootloader, which was the partitions boot sector, but it seemed like it was reading a list of memory addresses and disk sectors and just like copying those locations from the disk into memory and then running the program. So it seemed like it was doing the equivalent of loading a file, but without actually having to read the partition table or the file allocation table. It does have a file name in it, so it kind of seemed like it might be like at least comparing the file name at some point, but maybe just for, maybe just like within some header or as part of some validation. Like it seems like it's actually not reading the file allocation table proper and not actually reading the partition table at all, but it uses hard-coded locations. So that's all pretty typical for a bootloader. 512 bytes is not really very much, so it's pretty common that you hard-code a list of locations for that, first, or in this case, second stage bootloader to load. So all of that seemed to be working in emulation, and that's the end of the 16-bit code. So now we're in 32-bit code. We're loading, I forget exactly how big it is, but I think it was on the order of like 40 kilobytes or something for this next stage bootloader. So it's a bit more complicated. It's probably written in a higher level language, like C instead of assembly language. And it has a simple command line. It has some understanding of files and disks. It seems to be interrupt driven from what I've seen so far. It's using the CPU in protected mode and seems to be running a relatively small amount of code in its like main loop, and it has set up interrupt handlers for the hardware. So it, I don't know for sure, but it seems likely that that's using I/O ports to communicate with the disk directly. It seemed like maybe the problem here is just that it couldn't talk to the disk because of some weirdness about how this motherboard's kind of disk controller responsibilities are split between the system on chip and the Super I/O expansion chip. I don't think that's it though. So running it in QEMU, we get this file not found error, but it's a little suspicious. Like we aren't actually getting any disk reads if we retry the operation. The file not found doesn't really seem to correspond with the disk activity I'm seeing. So this is ringing a bell here. Like I think we disassembled some of this code several years ago, last time I was working on this project, and I don't think we totally got to the bottom of it, but I'm pretty sure that file not found error is actually fake, and the bootloader is actually sending an undocumented command to the compact flash card in order to check it somehow. And if it fails that check, then it pretends that something has gone wrong in this sort of obscure way by just like not talking to the disk anymore and immediately giving you file not found errors. So it's pretty weird. I don't know if it's worth digging into further, but it seems like pretty clear from what we've seen so far that it's sort of some kind of, either attempt at like having a serial number on the storage or just like an outright sort of obfuscation or copy protection scheme, and doesn't seem to be like a BIOS compatibility issue. Tuco's purring. So I'm running QEMU system here. This is just the standard binary from Ubuntu. I didn't compile it myself. We're tracing sector reads and writes on the IDE controller. I also wanted I/O port writes for the interrupt controller, the PIC, because that was a good sign I could think of that we were transitioning from the boot sector into the sort of PSOS boot 32-bit bootloader, because that latter program does a bunch of interrupt initialization right at the beginning, so we'd be able to see that. And then I also wanted this IDE exec command, and that was when I started remembering that, like, yes, I wasn't imagining things. I did actually see this thing years ago on the logic analyzer sending weird commands over the IDE bus, so maybe we can reproduce that in QEMU. So that's where I was here. So yeah, we get this file not found. Let's pick IO port writes. Actually, let me run this with just the hard disk IO so that we can see that interactively before we look at this in detail. So yeah, here's all the hard disk IO and those pick IOs that it was doing during boot. Now we have this file not found prompt. It's like you press down all the modifier keys to scale this. So you'd think that if you enter something new and then like try to boot. So what are we actually doing? Right? This is not actually reading anything from the disk. It's actually sending this command 1F, which is a reserved command. Normally this is at the end of this range that was used for recalibrate on some legacy devices. So this is either something that was already available in the firmware for this particular CF card, and they just used like the internal documentation for this card, or this is something that they ordered custom. So my guess is that this is just some kind of like internal like firmware serial number or something that they are requesting from the card using a command that is not actually standardized, and that if it fails, the bootloader gives us this file not found error instead of actually doing any normal disk IO. I don't think we can change the drive here either. I wonder if it was actually trying to access the floppy drive there. Anyway, so we changed from maybe the hard disk to maybe the floppy drive. Let's see if we can change back. Yeah, and no sector reads, just that 1F command. So I'm pretty sure we were here a few years ago. I'm pretty sure we looked at PSOS boot and saw some of this. I don't know if it's worth going too much deeper into this, like unless we actually want to get this thing to boot in QEMU for fun. This is pretty good evidence that it's not the same problem that we were having running DOS. So it might be fun to just try some different operating systems and see how they boot. I'm pretty sure I got syslinux booting on this before, but I don't know if it's actually that useful to run Linux on this thing. I kind of wanted to run like Windows 3.1 on it. FreeDOS's bootloader did not get past the MBR, so we could debug the FreeDOS MBR and see what was going on. That toy bootloader that I wrote a while ago wasn't getting past the A20 gate for some reason. And then once I patched that, it wasn't getting past some other disk I/O issue. I've got a hunch that we just have to patch the bootloader to hardcode the hard disk as OX80. That's my hunch. But I also kind of wanted to try like actual MS-DOS on these, since I suspect that might be what they were testing this with during their original development, and I don't get the feeling that they were intentionally trying to get this thing not to run DOS. It might just be that they didn't compatibility test it with anything except like one operating system, and so maybe it's worth trying a couple. Any response from this touchscreen? Nope. Yeah, I guess I'll have to demonstrate the printer some other time. I don't think I can actually get into the printer test without the touchscreen working. I don't know why the touchscreen's not working. So let's make a flashcard image that boots DOS. I'm feeling lucky about this 64 meg card. This is the one that I at least got syslinux booting off of before. I'm pretty sure it's possible to get Linux running on this thing, but I don't expect it to be straightforward, and I'm not really that interested in running Linux on there, except as maybe a development environment. Seems more interesting to run like period appropriate operating systems on it, which could be like old versions of Linux, but you know, it seems more interesting to run something like DOS or Windows or like weird proprietary operating systems on it. So anyway, yeah, Command 1F, probably some kind of copy protection. We can save that for some other investigation if we feel like it. Yeah, just keep some notes on that for later. All right. QEMU sus. Oh yeah, ready to install DOS. I'm hoping I can actually switch disks somehow. project. Change? Why did I not see that command? Ah, it's nestled right in there. Okay. Oh, what was it even called? Oh, it's so convenient when you know how to do it. Oh yeah, I've got debug. Best program in DOS. Oh, Tsuko is so good. I don't remember where stuff is in memory in DOS. That's the screen buffer. Yeah, anyway, let's try to boot this on the actual machine. Tuco is always sitting right in front of what I'm looking at. This CF card reader situation is a little flaky. Sometimes it doesn't even enumerate properly, and it gives me a device that is non-writable and has a fake size like 8 gigabytes. Why is that copy taking so long? It's a good question. Is the new studio set up 80 to 90% sacrificial decoy cables? No, actually all the cables here are there for a reason. But the like split loom tubing stuff is certainly for Tuco. I'm pretty sure I set this up recently enough that you could still point to any cable and I could tell you what it's for without too much effort. Tuk. Oh yeah, there's this, I think, a question about that notes thing I had. Yeah, that's my internal Nextcloud setup. It's been handy for sharing stuff between all the studio machines, especially. Slow card. Oh! Touchscreen works. Ha! It just needed me to be patient somehow. Like, now I'm wondering if this is another kind of analog problem or what. Like, I mean, this is like part of why I wanted to have the CMOS battery attached, is I'm wondering if there's some setting that it needs for the touchscreen that takes a while for it to reinitialize, and maybe having the CMOS battery helps. Anyway, it's working at the moment for whatever good that does us. Trying to find a lazy setup where this doesn't fall over. printer is big. Okay. Huh. That's interesting. This reports the calibration didn't change very much. Okay. Should rotate this in portrait mode now that we're doing application stuff and not BIOS stuff. I think this button's equivalent to the other menu we were in. Let's try it. Yeah. Oh, don't. Tuco loves printers. Oh, honey, I know you love printers. not distract him while this next thing prints. Okay, so 2 ways of getting into the same LCD calibration. Oh, Tuco. Tuco's. Tuco. Honey. That's a good question. Someone's asking if there's any network traffic. This machine is not directly network attached. It uses flash memory cards, which are then tabulated on a piece of Windows software, which is actually attached to, I don't even think the internet, but like some kind of modem network or something. I don't know much about that side of the program. Oh, Tuco. Oh, honey. Mischievous fuzzboy. Oh, makes that same click noise. Oh, Tuco. No. Tuco's very interested in that. This has the printer's character set, the serial number of the machine, the firmware version, and the date and time. Alright, now let's try, I think, the remaining menu option, which is probably saving the best for last. Tuco is going to be all over this, though. Oh man. Got 110 votes for Obama and 33 for McCain on this one. Oh, the screen just finished, like the software finished sending the data to the printer. So that is one thing the printer is for. I think the printer also prints out like individual receipts for each voter, but I don't have the cards to get that far in the software normally. Yeah, so the data that it just had was from 2008, and I don't know how many total elections this thing was used in, but you can see how many total votes were cast. That's the protective counter there. It's just like, it's supposed to be a non-resettable value. I think it's just stored in an EEPROM on the logic board here. So I don't know if there's any actual hardware protection for that to be hard to reset or something, but the idea behind it at least is that you can't reset it, that it just increments every time a vote's cast on this machine. Yeah, so as far as I know, that's all I can actually do with the software as shipped, like without modifying it. Let's try that DOS card. Yeah. Similar to FreeDOS, just a different, like, actual piece of text. This will also turn itself off. Yeah, like it just did. And that's due to this startup timer. It's actually a 555 chip on the board, and whatever number of seconds that was, like 30 seconds or whatever, if you don't make some I/O writes to shut off the timer before then, it'll just shut the machine off. So presumably to keep it from just draining the battery if it doesn't successfully boot. That's funny. So what I just did there is I hit the reset button, which sends like a bus level reset to the system on chip. I hit that, which did not reset the 555 timer, so we got a fairly early power off there. But it did cause the system to do the very early parts of boot with the LCD already turned on, so we got to see a message from the VGA BIOS, which we usually don't see. So I think it'd be fun to take apart this MBR and see if we can patch it to work on this board. Could this be the same MBR we saw earlier? Was I wrong about that being a custom MBR? I really thought the DOS MBR had different messages than this, but here we are. Yep. Alright, so we already took this apart. We took this apart yesterday, and it turns out that that was the same MBR DOS uses. Great. That saves us a step. So we already know that this just relocates itself down to low memory, loads the partition's first sector, and then transfers control to that at 7C00. So I think this is succeeding, and our problem is in the next stage. That's interesting. So this was actually hard coding that hard disk ID. Is that like normal behavior for DOS then? Maybe they modify that every time they install the MBR, like to reflect the correct disk ID. I don't know. I'm not going to worry too much about that because that's not the part that's failing. Is that not where the error is coming from either? This is where our old friend non-system disk or disk error comes from. Maybe we're getting further than that. What was that again? It was like operating system not found. Missing operating system, okay. Maybe we're getting further than this. I wonder if that's coming from the BIOS and its fallback interrupt. Hmm? Oh, never mind. I'm just dense today, I guess. It was totally coming from the MBR, which was my original suspicion here. That's interesting. So this is the same MBR between the original firmware and DOS, but it's a different MBR from FreeDOS. FreeDOS's MBR was also failing, but with a different error message. It was like partition signature is not F or 55AA. Let me verify that. we already had FreeDOS in here. Oh, I have FreeDOS in here. Yeah, okay. This must be where I was getting confused, is like FreeDOS has a very different MBR here than MS-DOS, and for some reason they copied MS-DOS's MBR in the voting machine firmware, which does not run DOS. Okay, but they're probably having basically the same failure here. So was I wrong about that disk ID hard coding stuff? Yeah, I mean, it is a good point that those MBRs are not identical. It's possible that's like a patched DOS MBR. So that stuff at the end is the partition table. Yeah, those are just different because the disk has a different size. I don't think any of the relevant parts are actually different at all. Yeah, only the partition table is different, and not even the disk ID part that would make a difference to this other theory I've got. So they're really only different because the disk is sized differently. So yeah, this really makes me doubt that anything is actually weird about the MBR's disk ID byte handling. So this is where we read from the disk. This is a retry loop around it. I don't know why we read from it a second time with the size zeroed out as part of the retry. Missing operating system is what we're getting. This is here. Okay, this is functionally the same as the FreeDOS error. This is, so we fall through here on success or failure. We're just setting this up in case of failure. And then here's where we're actually testing the error, and it's just against, this is literally just the signature of the BIOS already loaded. Do you think the BIOS is intentionally messing with the partition signature just to keep other applications from loading? Do you think that's what we're doing? We could look at that part of the BIOS. Like, it might be interesting to find some evidence of it actually. Because that would be one theory, is that they just wanted some like easy way to make their system a little bit more of a black box to people. And so they put in some kind of extremely cheesy way of preventing the BIOS from booting other applications. Well, let's try to follow that theory for a minute. Okay, I want to find that OS initialization stub string that comes up. How do you do strings? This is it. I'm guessing that this is fitting into some kind of like module system that the BIOS has. Like, you know, it's loaded at a very round number here. It seems like this is a chunk of code that's like separate from the rest of the BIOS. So I'm guessing that like the way the BIOS was distributed, there's like sort of an in-firmware application you can write. And that's probably what we've got here. And I'm guessing we're going to find something that is similar to a standard MBR load, but not quite. It'd be funny to patch the BIOS to make this load normal things, but I mean, the most straightforward thing to do here is going to be patch the MBR. We could write an MBR that loads, you know, the registers for disk number or whatever it is that this is actually missing. And it could also turn off the watchdog timer. Is this going to have some kind of like signature at the end so the BIOS thinks it's an option ROM? So many zeros. All this space to add applications to the BIOS. I was kind of curious how they did BIOS development for this machine. Like, my guess is that they left the BIOS chips unsoldered, and then they had some kind of add-on card that let them do ROM emulation. I don't know if this is the same piece of code or different. Anyway, so I assume this is an entry point for whatever this is. I don't know if this is a message we're displaying within this chunk of code or whether this is used. I mean, I guess this is probably just like a printf or something. Yeah. This is like a put string. What segment was that? Oh, you're gonna sit. I'm gonna sit right in front of the screen. Okay, so we're literally just popping up that message there and then making it int 19. So was int 19 that that usual like fallback loader we were looking at before? I should just download these. Why are they in so many separate files? Gosh. Maybe they did the laziest possible thing, which is they had their OS initialization stub literally just do nothing, which is probably why it's called a stub. And then they hacked whatever this hypothetical modification is into the stock BIOS loader code instead of writing their own copy of it. Can we find the interrupt table? Is this the interrupt vector table? No, that's the VGA BIOS. Oh, to go. Oh, am I gonna find the interrupt vector table just so that I can find this next piece? I need a quick restroom break. I'll be right back. Kitty. Kitty. Oh, what if we found a IVT somewhere? It would be funny to try to run this BIOS in an emulator. I don't know how far it would get, because it probably hits motherboard-specific hardware quite early on. Like, you know, initializing DRAM. And, you know, it's certainly possible a lot of that stuff just would fly by and the emulator would ignore it. But I think some of it is likely to end up in a hang, at least. This is where it would be cool to have, like, source code to the vanilla, like, vendor-provided BIOS that they used. That would be difficult to find, probably. One strategy is to look for an interrupt handler that should be pretty easy to find, and then look for pointers to that somewhere. I might just try to skip a couple steps and just like look directly for something that seems like an MBR loader without trying to find the interrupt table first. Just work backwards from that. Like, we've got some messages too to go on, like this operating system not found. Does operating system not found happen after the OS code stub message? I should check that. What's that 0? That's cool. Sorry about that. Yeah, so it looks like this OS code initialization stub thing is pretty ignorable. And it runs regardless of whether or not we actually find anything to execute, and that operating system not found error is coming from inside of the interrupt 19 or whatever this is. It's a good question from the chat. Can I patch the BIOS or the MBR? Yeah, the question is, can I patch the MBR to print out the checksum that it's reading as well as the checksum it's expecting? Kind of. I mean, well, so first of all, that isn't even a checksum. That's just a 2-byte signature that it uses to identify whether something is a like boot record at all. So it's really basic. It's not even a checksum. You could print that out. It's just that this whole thing has to fit in less than 512 bytes of code. And like, there are no library routines for this. You can make BIOS calls that do things like print a character to the screen, but you'd need to, for example, convert the character to like ASCII first, you know, do a little hex lookup table kind of thing. So, you know, totally doable, just slightly annoying, and I don't think we even need it. But yeah, one thing we might try is making a modified MBR that just hex dumps itself, and then we could see if the BIOS is loading it correctly or modifying it. So where is this? This is near the end. The stuff near the... So just for like general lay of the land here, the stuff at the very beginning here, so in the first 64K of the BIOS, that's the video BIOS. So this thing that starts with IBM VGA compatible chips, 6550, whatever. That thing is the video BIOS. I don't really care that much about it because we have pretty good documentation for the video chip. Then that OS initialization stub thing is this largely empty section that starts at, what is this? This is at the 64K boundary. The OS initialization code stub. And so like this is the thing that launches the BIOS's normal operating system loader. This is their print string routine, and then everything else is empty. That whole 64K segment, I think, except for maybe some stuff at the end. And this is in the next segment. Lots of empty space in the BIOS. I don't know what this is part of. So yeah, there's some stuff here at like in the high 2 segment, which I don't know what that is. But then this like 3 segment is like the main part of our BIOS, and the lower level parts of the BIOS seem to be near the end of this. And like the very last 16 bytes is where the CPU reset vector lives. And then a couple kilobytes before that we have the compatibility segment. Anyway, that is near where this message is. Should mark some of this code so we can find pointers to that message. Got some interrupt handlers here. Always nice to see a IRAT. That's not code. Looks like maybe a function. Like, definitely not real, because this doesn't even have a floating point coprocessor, and I doubt they would be using emulated float in the BIOS, right? That looks real. These might be real. Oh, can I not go there? Someone asked what my cat was staring at. I don't know. Huh. Hmm. There's a lot of stuff outside that Tuco likes to stare at. Sometimes we have visits from neighbor cats. Anyway, I don't know what this intervening junk is here before the string. That might be some other data table. Might be some code that I haven't aligned right. But this stuff looks relevant, right? Here's a 7C00. And that int13, or sorry, int16 here was waiting for a key, or checking whether a key is being pressed, which is also like typical boot up behavior. Where's the start? Are we putting the stack in the BIOS data area? Yeah, I think that's what we're doing. I think we're putting the stack and the data segment in the BIOS data area. This looks like it might be a handler for an interrupt, like, I keep reading the number, what was it, 19 that we were looking at? And some of these ES offsets could definitely be like strings or internal variables. Huh. Let's see if the decompilation makes any sense, maybe. Okay, so 7C00 is interesting because it's the load address for our boot record. I think this is a big retry loop that everything's enclosed in. It looks like this is going to be press a key to retry, and then we wait for a key, and then we're just going right back up to the top. I don't know why that's not lining up right, but this is acting like a print function kind of thing. Eventually getting the hang of their window docking system. Is this reading the second sector? Or is that numbered from 1? I probably numbered from 1. Can I put comments in here? Apparently that went on the entire function. Oh, that's better. Now that I define this as a function, the decompiler changed this to a tail call to itself. Okay, there's a lot to look at here. I saw some, okay, like this AA55 might be interesting, since presumably the BIOS is actually checking the partition signature. Let's make a note about that. Oh yeah, and it's written this way because it's, like, this is the end of the 512 byte sector, but we're addressing it, at least as far as the decompiler is concerned, as an array of 16-bit integers. What is 18? Diskless boot hook. Yeah, good luck with this decompiler. A stack push inside a loop. this is going to be actually running the code, right? So we're making a return address. What is ES going to be set to? I thought ES was maybe zeroed. Yes. Should move that from under the cat. This is a flag in the BIOS data area. I forget what this is specifically. Not documented. This is a handy little memory map on the OSDev wiki. So real mode, interrupt vector table, BIOS data area, which is what we're looking at right now. At the beginning of this handler, we point a few of the segments to this area at 400. This is like regular DOS memory. This is where the boot sector was just loaded. We a couple of times put the stack for the boot sector in this conventional memory area. Bunch more memory after the boot sector in that region above 64 kilobytes. Then we have some bus mapped stuff like the video card and the BIOS ROMs. So I think this is ORing a bit into 415. Could be something specific to this BIOS. What is DX? 0 maybe? DX should be the drive number, I think. Anyway, I should pay attention to the disk reads here and the loops. So there's this first section that's like all gated under this if. Checking some flag, where is that? This is like an empty hook function, maybe. Okay. This is a disk read that's being directed at 7C00. This is copying 7C0 to ES. Since we're in real mode, the way the addressing works is that the segment selector is multiplied by 16 and added to the offset. So the offset is set to 0. This acts like 7C00 linear. CX is the number of sectors to read. Okay, this is actually reading the MBR. So something down there was reading sector 1. That's a good question. Does Tuco ever go outside on walks? Yeah, he's a really skittish boy, so like I have to keep a close eye on him. But yeah, we go out together sometimes. He doesn't seem to want to go like out on to the front of the house, like where there's traffic or anything, but he likes hanging out in the backyard. What is this return value it's testing? What? Hmm? What? What? Hmm? Is that what you wanted? It's cold. Okay, so that looks like a disk changed status that it was checking. Oh, Tuco. Don't know what status 1F is. Oh, Tuco. Oh, sorry, this is test, not compare. So this is just checking to see if any of the status bits are set. Tuco, you're in such a mood, honey. Oh, kitty boy. What did we put on the stack? Tuku? Yeah. Hey. Bossy man. Yes. Oh, bossy. Oh, no, it's too girl. Okay, okay. What? Do you want to go? Gosh. Okay, so here, what do we have? We have pointer to the thing that we just loaded successfully. Guessing SI, some kind of retry count. How do we actually set DL? Right, it looks like DX is going to be tracking the disk ID / boot flag. What is it 13.0? Reset disk system. Okay, so this is probably just some attempt at recovering if there's a problem. Or maybe we're just telling it to stop for some reason. Something interesting at 478 in the BIOS data area also, and I don't know what that is. It looks like a pointer that we can set to one of these several values that are nearby. Are we really reading the second sector here? Gosh, Tico is so frustrating sometimes. Hey! Tuco. What? You wanted to be in here? What do you want, boy? What? I thought you were hungry. Tuco, you're so weird. He is such a complainer. Alright, the indexing. Oh, Tuco, why are you doing that? Tuco. Okay, boy, honey. Jeez. was misremembering. I thought the sector count was in CX, but that's the sector number and the cylinder number. The count is actually in AL. Where does AL come from? This looks like it's set up to load more than one sector in its initial read. So it's got some like BIOS data that it accesses through GS segment. Anyway, that's probably fine. Also, it looks like we've got some debug trace stuff, or maybe something else. I don't know. This first function that's called had a bunch of IOs. So I don't know whether that's talking to some hardware or whether it's debug trace stuff, but it seemed like maybe stuff we could find on the logic analyzer. This one. Port 70 and ED. CMOS RAM. Ooh, ED might be a trace register though. These could also be real-time clock reads. Like this might be some debug timestamping stuff that goes out to port ED. This ED stuff looks like debugging, but I think the main function of this is to read something from CMOS RAM and return it. Anyway. Actually, I do want to know what that AX is for. Is that... Because if that goes out to an I/O port, that would make it easy to actually find this on the logic analyzer. Oh. Oh, it's like a control bit field. This is probably configuration information about like the boot order or something like that. Is this like a disk or partition number, maybe? Oh, where's our stack here? I think the stack is probably in a implementation defined area when the boot sector starts, but I don't know. It's like we're using our stack as a kind of trampoline to get into the boot sector. There's no special effort to set up the stack before entering the boot sector. But there's this loop where we just push 16 zeros onto the stack. I don't know if this is like an actual argument we're sending or if we're just making room. Oh no, that's what we're doing here, pop AD, because yeah, otherwise this wouldn't be balanced. So we're saving DX here and clearing all the rest of the registers. Right, DX, like, this should be our OX80 in DL. This document's mostly about the interface between the BIOS and like expansion cards and devices that you might want to boot from that are not implemented in the BIOS itself. But it seemed like it might have some interesting context. Oh, interesting. I guess it used to be common to have the drive hard-coded for hard drive. Does anybody define DH? Anyway, nothing seems unusual about the disk numbering. Like, it seems like it's passing that to the MBR code through DL like you'd expect. Like 90% of this function is like retry and error recovery logic. Yeah, none of this is weird so far. Maybe it would be worth the trouble to make a little MBR that just hex dumps itself. That might be a useful thing to have, I guess. I don't know. Oh. We're gonna be lazy and like search for it before just writing one from scratch. This is a very specific thing. I doubt anybody would. Right, nobody would make a self-hex dumping MBR. What should this actually be? Should this just be a little real mode program that hex dumps itself wherever it's loaded? Or hex dumps the code segment? Does that even fit on the screen? Yeah, we might have to make the sizes weird, but we can fit that. Okay. Fine. Are we doing this? Ooh, am I running out of memory? I should have exited Gidra first. I can have an easier time SSHing in and killing Gidra. Is this already hung? Great. Yeah, this machine doesn't have nearly enough RAM. Maybe we just uncleanly reboot it at this point. Welcome to the rebooting channel. Cleaning up all those poor orphaned inodes. Okay, let's write some assembly. could steal some code from my past self because I've written some bits and pieces that would be useful, but it's probably a good exercise to just write it without cheating. Okay, so we need a hex dump routine. It's pretty common to just use a lookup table for hex dump nowadays. I don't know if it's actually smaller to write code to do it though on x86 real mode. Is that even anything close to what I want? Remember, we're not in GNU land, we're in NASM land. Any of those combinations should work. I must be just using the wrong assembler syntax. Oh, is that how segment overrides work in NASM? Let's disassemble that to make sure. should set up the stack, right, if I'm going to use the stack. I don't know which registers we can rely on. This would be a little simpler if we just don't use the stack at all. Maybe CX? CL. Compiles, assembles. So we're clearing this counter, loading a byte from the code segment at that counter, keeping track of the number of bits we're shifting that by, and starting out by shifting it by half a byte, masking off just that byte, checking to see whether it's in the alphabetical or the numeric part of the hex table, I guess, even though it's not a table. So we're either adding 0 or adding A. Oh, this should be A minus 10. Let's just try that. Oh, we did not make that bootable. I think the code I was, like, the last time I did real mode stuff, I was using GNU tools, so there are a few things I'm used to doing with GNU's assembler that don't work with NASM. At yeah, thought we were gonna have to go there. This is actually the same problem I'm solving. Top, huh? How does dup actually work? Times. I think dup was for a different assembler. Yeah. Do we still have the $sign for the current address? Oh. Yay, 512 bytes. Well, it booted and it did something that was not correct. Oh. Oh, right. Seven. Which part of that am I getting backwards? Right, it's ending up on the hex alpha path here when it shouldn't. I think the digit path is fine. Just wanted to test that. Yeah. At least NASM, the order of everything should be the same as in the Intel manual. I think I'm just confusing myself about the order of operations for compare. Subtract the second from the first. So I was trying to subtract OXA and then jump on the carry. I guess I want to subtract 9 and jump on the carry. Was that the problem? That wasn't the only problem. Okay. That's better. And the whole thing. It's probably just an issue with SI not being preserved. Well, if that was the case, we wouldn't be looping the right number of times. Oh, right, the code segment does not actually point to the beginning of the bootloader. Let's use ES for this. Can I assign directly to ES? Oh no, I don't think so. Yay. That looks right. Okay, we have a self-hex dumping MBR. I guess it should have a partition table too. I don't think BIOS cares about the partition table. Really shouldn't. It should just look for the 55AA and then jump to it. Alright, so we've got our tiny MBR. Let's try sticking this in a card and running that on the actual machine. Okay. That looks correct. So at this point, it's looking like this is a problem with loading the partition boot sector. next thing to do is to debug why that toy operating system's bootloader wasn't working. Since that's something that's simple and I've got code for. That's interesting. We could also go into, I mean, what possibly could be wrong with this? Let's look at that code for the MBR again. Chomp, chomp, chomp. So we're getting this missing operating system error. 62. Oh yeah, I think last time I looked at this I was momentarily spacing out that it's relocated itself, and so this 7DFE is definitely the partition and not the master boot record. I wonder if this whole thing is just a CHS addressing issue. This could entirely be a CHS formatting issue. How would I work around that? I wonder if it would be worth just like copying the partition layout from the original file system, or the original card. Like that's just a combination of things that's actually pretty straightforward that I don't think I've tried yet, is making a copy of the original image and leaving the MBR in the partition table, but just replacing the partition contents. Let's try that. I'm going to do that by installing DOS over top of the existing card in QEMU and then DDing that onto just an arbitrary CF card. So it'll be a 16 megabyte partition on a larger card, but that's fine. I just want something that'll boot DOS at this point. I already exited. Good job. All right, let's install DOS again. Could add the disk after booting, or change the boot order maybe. There we go. We're keeping the whole file system even. Should I at least delete the files? Well, maybe we'll just do this. We'll just have a file system that is clearly DOS installed over top of the voting machine firmware. Okay. What a mess. Okay, so we have DOS and all the voting machine stuff on this card, and there's like a megabyte free. But that's fine. Let's just see if this even boots. Actually, let's see what this looks like on F disk. FAT12. Yeah, so just to be clear, I think the difference here would be that the partition layout is different in subtle ways, like that old BIOSes with CHS concerns would care about. Why so slow? What? Oh, right, this was I was trying this out on a 4 meg card. I should really switch to a 64 meg card or something. I'll put the hex dumper back on here, why not? Duco left a toy in here. Okay. Ah! Oh my gosh, it was a partition formatting issue. Ah, it's a DOS prompt. Ah, okay, we still have the watchdog timer. Great. Let's write a little program to shut off the watchdog timer. Gosh, what an annoying problem then. So that means our total actual set of problems for this, we had a missing jumper. There was a missing jumper that kept the clock from actually starting up at a stable frequency. And there's the watchdog timer. And then there's, I apparently can't format a working compact flash card that this BIOS actually knows how to read because legacy hard disk nonsense. So yeah, the MBR is totally fine. There wasn't anything, there's nothing weird about the BIOS as far as I can tell in the boot process. Like, I wrote a little hex dumper and, managed to disprove my hypothesis that maybe the BIOS was messing with the signature at the end. Pretty sure the only thing that's weird about this thing is that it's old and has some kind of half-baked watchdog timer built in. So, speaking of half-baked watchdog timer, let's make a little program to fix that. Okay. Let's make a little dos.com file. Oops. So before .com meant a commercial website, .com meant a DOS command. So this will just take some I/O output, and we need to return back DOS. So Yeah. G. Okay, DOS interrupt 21 AC4C is the normal exit that we want. So let's delete all this. I don't know why I grabbed the assembly. So this is enough to successfully exit from DOS. Let's just make sure that builds and runs. Cool. So we have a DOS command that runs and does not crash. It returns to the command prompt. We could also make a intentional power off command if we want, maybe. Okay, I did actually test this. Oh. Yeah, so we wrote this code a couple of streams ago and just dumped it in some random MBR as a way of testing it. And this is derived from the notes I took looking at the oscilloscope, and that also confirms the hypothesis that this 140 is not necessary. That seems like it was just some unrelated initialization. So and of course, this is a different assembler. I had kind of tried to squash this code down to keep it in this tiny space available, but since we have an entire 64K segment here, I'm just going to make it large and easy to read. Let's try that. So we can stick this on the card. What is the easiest way to do that? I think we can just mount this on the Raspberry Pi normally. Do we want to use M tools? I don't think we need to. Might as well just remove the stuff that we don't actually need. sram.bin. Feels wrong having a lowercase file name. Did that work? I think that worked. I don't think we've had it booted for this long before. Oh, that's great. I wonder if we can repartition this somehow. Like, right now I only have one device that I can store files on, but surely I could find a way to hook a second thing up here so that I can use, I don't know, I feel like using this BIOS to partition the card might be useful, but we could also just look closer at what is different in the partition table, since this is definitely just a partition layout issue that was keeping it from booting before. So we've got it in DOS. We've got a simple program to shut off the watchdog timer. That's pretty cool. I kind of just want to try running some stuff on it now. We have a debugger. Cool. Yeah, I don't think I can like swap anything either. Like nothing here is hot pluggable. Like it's a compact flash card, but it's pretending to be an IDE hard drive, and I don't think anybody would be happy with me trying to hot plug that. Anyway, we could even theoretically add a floppy drive. That would just require a bit of soldering. Oh yeah, we should actually have a program to power it off. I want to write a little power off utility and then maybe throw that and SimCity or something on that card. Is 5.7 the normal value of that? No, 2.7. So we're turning on bit 40. Yeah, that's probably just turning this back on. that. I don't think we quite have enough space for that. I don't know what we're going to do about mouse. Is this at all playable with keyboard? That might be a problem. I imagine that this would just complain about no mouse driver. Can I simulate that with DOSBox? Oh, maybe we should just try something else. I need to figure out how to make larger cards that work, though, if I'm putting anything big. Like, I don't think I can fit Windows 3.1 in 7 megs. Be handy if I could have like a RAM drive or something to run stuff off of while I like reformat the main card. There also might just be some like tools in DOS I can run to see what the BIOS thinks this disk is actually structured like. Panel mount trackball. Yeah, I mean, it would be kind of cool to get SimCity working on the voting machine. The machine has a touchscreen, of course. I don't actually know how the touchscreen's connected, so that would be another thing we could debug. That might be a good next actual reverse engineering task, honestly, if we wanted to get the touchscreen working. But right now I'm just kind of looking for something quick we can run just to celebrate actually being able to run DOS on this thing and have it not turn itself off and not fail to boot. But we might have to do without a mouse. There's no mouse emulation for DOS. Was this even a thing? You could try Robot Odyssey. That certainly runs without a mouse. Mouse or joystick? Oh, and there's a keyboard. Copy protection. The red sheet cannot be photocopied. Okay, SimCity can be played without a mouse or joystick. There's a keyboard reference chart. Cool, okay. It's also possible that because it detected the mouse, it is doing something different than if the mouse wasn't attached. Cursor keys, insert and space. Okay. Let's just try this. I'm doing the right cache. All right. I could be imagining something, but I think the printer turned on when my Watchdog timer off program ran. So I'm wondering if that's also on the same I/O port. Oh. Really? So this is cool. We could totally add a sound card over the PC104 port, but right now all I've got is PC speaker or nothing. This is really annoying to play with the keyboard, and that PC speaker music is getting old already, but it does seem to run. It's in a little window in the middle of the LCD. Music off. This is bringing back strong, like, early 2000s or late 90s laptop vibes. That's fun. It's certainly not a keyboard-friendly game, though. All disasters, sure. Oh, I picked up the window. Oh my gosh, if the mouse wasn't so annoying, I would play SimAnt on here. Oh, it's the twister up there. Oh gosh, do I have to go to that little window every time I want to scroll? Ooh, no? Okay. Oh man, fiscal. Someone's asking what audio lib can work on the VM. I don't know what VM you mean. The one I was using for debugging earlier. I think QEMU supports a handful of things. But this is not running on a VM. This is running on a 486 system on chip in an old voting machine. Oh, VM for voting machine, gotcha. Yeah, no, it doesn't have any audio other than the PC speaker. All right, take that back. There is like a accessibility, like voice assistance thing, but that's actually done by some kind of external module that I don't have. So this unit has like a serial port that you plug into some external device that plays back sound samples, but all it knows how to do is beep. Should we see if it'll run Doom? That might be a little easier to play without a mouse. I think this is either 33 or 66 megahertz and 32 megs of RAM. I'm going to test my power off script. Nope. That failed. At some point, I'll want to debug why my power off script does not work, but maybe not right now. Does not work. Yeah, no, I agree. There's a comment that the music on SimCity was really good, and it's a shame we can't have that on the voting machine. I mean, we technically could. I was looking around for PC 104 stuff recently and noticed somebody made a PC 104 sound card that has a bunch of different compatibility modes, including Sound Blaster. So we could theoretically find something like that and add a Sound Blaster. Alternatively, I've got all these logic analyzers hooked up to it. We could probably find a way to add a software emulated Sound Blaster to the real 486 if we wanted to go that route. Is this going to be really big? I thought there was a version of Doom shareware that fit on a disk. see if I can make a small version of this that runs. I don't know what that is. Oh man, just that doom.wad is bigger than the free space I've got on the card right now. Oh, I forgot to delete ram.abs. That's the actual voting machine application. It's somewhat big. Do I not have any keep bindings? Oh, this is mouse mode. I might be missing a config file or something, but I might just try that. Okay. RAM drive, that might be necessary. Okay. That was a tight fit. Okay. Demo mode. Oh, we've got that great vintage LCD viewing angle. seems to work fine. I wonder if there's any chance I can get Windows to fit on this card, because I would actually like to run Windows 3.1. It's likely I have to debug this partitioning issue a little further and get this working with larger cards before I get there, though. Alright, I don't know how much I can strip away from Windows to get it to run on this. Try that. Why is temp set to SQL and DOS by default? Oh. Maybe you can play solitaire with the keyboard. Gosh, if there's actually a way to like, copy DOS to the RAM disk and then use that to reformat the CF card, that would be cool. Anyway, it feels like it's pretty late here. What time is it? Oh, it's not as late as I thought it was. Let's try that maybe. Huh. I tried to reboot with Control-Delete, but that didn't seem to actually work. right, no command line editing. Let's not worry about Windows. I don't think DOS knows how to resize, or sorry, redo partition tables without rebooting. That 4 megabytes is how large the BIOS thinks the disk is. We can change that in the BIOS. It seemed like the whole voting machine firmware part of this was designed to work with default BIOS parameters, but yeah, maybe if we're running DOS on this, we need to change the BIOS parameters too. Yeah, I don't think Control-Delete actually works. What? Oh, right. Watchdog timer. I have to be a little faster than that. We've got to reboot again. I didn't actually make it to the watchdog disable in time. Yeah, I bet the layout on that original card was kind of weird, since it seems like it was it was set up to boot correctly, but assuming the BIOS was set to a 4 megabyte disk and the card was actually 16 megabytes. I'm going to try this one more time using a different disk setting, something that's like not quite 64 meg, but I think I'm going to wrap this up soon, and on the next stream I'll want to dig deeper into like specifically what these disk layouts are and like how the BIOS is interpreting it and how other software is interpreting it. Because this seems like something that is weird and is set up in a not quite standard way, but that still works the way they're normally using it. So like we managed to get into DOS by just like copying the exact partition layout of the original system, and now I want bigger partitions. Oh. That's kind of handy. Oh, you don't. I don't have any of the example basic files. We defrag a RAM disk. Okay, I should end this stream before I just play with DOS stuff constantly. I'll figure out like a good set of actual next steps before the next stream, but I probably want to get a better idea of how to partition things reliably on this machine, and yeah, I don't know. That's probably not going to involve like reverse engineering so much as it's going to involve just like trying to understand what the implications are of BIOS and the physical disk, kind of disagreeing about the size. But yeah, otherwise things seem alright. I want to know how the touchscreen works maybe, and maybe some of this other hardware. But we have a regular PC in a lot of ways. We've got a regular printer, even though it's small. Regular ISA bus. So yeah, thanks for hanging out. We'll see you next time. I'm trying to actually stream every day, so even if they're not always 5 hours, I'm trying to actually do some work and publish it all pretty regularly. So happy hacking, folks. I'll see you all next time.